An analysis of a remarkably massive but compact galaxy in the early universe suggests that dark matter interacts with itself. The galaxy, JWST-ER1, which formed just 3.4 billion years after the Big Bang, was first spotted last October in images captured by NASA's James Webb Space Telescope, JWST. Located more than 17 billion light-years from Earth, JWST-ER1G is the most distant example of a perfect Einstein ring, an unbroken circle of light around the galaxy, the result of light rays from a distant, unseen galaxy being bent by space distortion mass of JWST-ER1. The cosmic mirage is not just a beautiful sight due to a lucky alignment of galaxies. This provides physicists with a valuable probe for model-independent measurements of the mass within the ring radius. Calculating how much JWST-ER1G has distorted the space-time around it, the team estimated that the galaxy weighs as much as about 650 billion suns, making it an unusually dense galaxy for its size. By subtracting the visible stellar mass from the total inferred mass, physicists can measure how much of the galaxy is dark matter, an invisible substance believed to make up more than 80% of all matter in our universe, writes Space.com. Despite decades of observations and abundant circumstantial evidence, the elusive substance has yet to be directly detected. In the case of JWST-ER1G, the discovery team determined that dark matter accounts for about half of the mass deficiency and that additional mass appears to be needed to explain the lensing results, according to a study. The value for the dark matter mass appears larger than expected. This is a conundrum, said Haibo Yu, a professor of physics and astronomy at the University of California, Riverside, UCR in the US, and co-author of a new study. If dark matter interacts with itself, this could solve many puzzles. In a new study, Yu and his colleagues suggest that JWST-ER1G's unusually high density could be explained by a larger population of stars than previously thought. However, a contraction mechanism by which ordinary matter, the stuff that makes up gas and stars, collapses and condenses into JWST-ER1G's dark matter halo could pack more dark matter mass into the same volume, resulting in a higher density, said lead study author Demao Kong of UCR. The dark matter halo, densest at the center of the galaxy, is the gravitational glue that keeps rotating galaxies from falling apart. Moreover, models that incorporate a specific type of dark matter, where dark matter interacts with itself, provide an excellent match to JWST-ER1's measurement, according to the new study. We still don't really know what dark matter is. Observational clues suggest that it is a new type of particle whose presence can only be inferred from its gravitational interactions with ordinary matter. Dark matter could be just one type of particle or a complex variety of different types, as in normal matter, operating perhaps in the presence of additional, as yet unknown, forces unique to dark matter. Last December, Yu ran simulations of the formation of structures incorporating dark matter interacting with itself, concluding that such self-interactions could explain extremely dense dark matter halos in certain galaxies, as well as surprisingly low densities in others, both of which can be explained by the prevailing cold dark matter theory. Physicists hope JWST can shed more light on dark matter. The telescope's unprecedented infrared looks further back in time than any other telescope, and its future investigations of galaxies in the very early universe could reveal clues about dark matter particles and their behavior, Yu said. We expect to see more surprises from JWST and learn more about dark matter soon, he concluded.